Alright, so here is a pretty stereotypical application of linear equations in that it's a pretty simple one to do, and it's pretty easy to wrap your head around, but I'm going to do it anyways. So it's about change, and by change I mean pocket change, coins. And so let's suppose you have 7 coins, which are dimes, specifically dimes. Those are worth 10 cents. And quarters, those are worth 25 cents in your pocket. And suppose you have exactly $1, which of course is 100 cents. How many dimes and quarters do you have? Well, let's turn this into math. The number of dimes plus the number of quarters you have has to equal 7 because you have 7 coins total, dimes and quarters. And, well, what is the other bit of information we have here? We know exactly how much money we have in dimes and quarters. We know that the amount of money we have in dimes plus the amount of money we have in quarters is equal to 100 cents. So the number of cents, the money we have in dimes plus the money in quarters, let me put a space here, is equal to 100. Well, how much money do we have in dimes? Each dime is worth 10 cents, and so if we have some number of dimes times 10 cents, that's how much money we have in dimes. Similarly, if each quarter is 25 cents, and we have a certain number of quarters, the total amount of money we have in quarters is 25 times the number of quarters we have. And we know that this is equal to 100. Okay, great. So now we have two equations. This one right here, which deals with the number of dimes and quarters, and this one down here, which deals with the number of dimes and quarters. And those are unknowns. So let's let x be the number of dimes we have, and y equal to the number of quarters we have. And now we're going to solve the linear equation. X plus y is equal to 7, and 10x plus 25y is equal to 100. Again, this says that we have x dimes, y quarters, and the total number is 7. And this says that x dimes are worth 10 times x cents. This says that y dimes times 25, or y quarters is worth 25 times y cents. And we have 100 cents total. So let's go ahead and try to solve this. Alright, so we're going to try to solve the system. X plus y is equal to 7, and 10x plus 25y is equal to 100. Let's do substitution this time, because otherwise we'd have to multiply by some pretty big numbers. And so let's solve this for kicks for x in the first equation. So if x plus y is equal to 7, I subtract y from both sides, and that leaves me with x is equal to negative y plus 7. Now I'm going to plug that into our second equation, so this is the substitution step, so we're going to plug this into the second equation. And so since 10x plus 25y is equal to 100, then I have 10 times negative y plus 7 plus 25y is equal to 100. I distribute the 10, which gives me negative 10y plus 70 plus 25y is equal to 100. Negative 10 plus 25 gives me 15y plus 70 is equal to 100. And I subtract 70 from both sides, which leaves me with 15y y is equal to 30. And finally, I take 15y equal to 30, and I divide both sides by 15, and this leaves me with y is equal to 2. So I've got 2 quarters. Now since x plus y, this is my back substitution step, x plus y is equal to 7, then x plus 2 is equal to 7. I subtract 2 from both sides, and I have that x is equal to 5. And so this tells me that I have 2 quarters and I have 5 dimes. Does this make sense? Well, 2 plus 5 gives me 7 coins total, and 2 quarters are worth 50 cents, and 5 dimes are certainly worth 50 cents, so 50 plus 50 is 100. Great, that makes sense. So again, all I was saying there is it's true that is it true that x plus y is equal to 7? Well, 5 plus 2 is indeed equal to 7. Is it true that 10x plus 25y is equal to 100? Yes, because 10 times 5 plus 25 times 2, is that equal to 100? Yes, because 50 plus 50 is indeed 100. And as an exercise, try to solve this by elimination. You should get the same answer. Alright.